This is a game that has come up many, many times over the years. It involves conditional chains. And again, like I said, there have been many games like this. And so I have a list of them if you want to practice a bunch, and I'm typing them in the chat here. There's the Birds in the Forest game from test 33. There's the Fruit Stand game from test 36. There's the Photograph game in test 45. And there is a Volunteers game in test 58. So this has appeared again and again and again over the years. Very important to have a handle on it because, again, it keeps coming back. I'm sending you a link in the chat as well to a bunch of games like this that repeated over the years. This is from category 1. Now, this particular in-out game is one that I wrote that I'll share with you just so that you can do more practice on the actual ones on your own. And this one everyone has access to because it's on my site. Now, this ties into a question that Colin asked me a little while ago. He was asking about conditional logic. He said, is conditional logic the #1 foundation for doing logic games? What are the biggest indicators of applying the contrapositive to the question stems and answer choices? And I feel like it's a big part of games, but you shouldn't be doing it for every single question. How does this relate to the foundation of logic games? So ultimately, there are 2 types of relationships that are very important to consider in these grouping in-out games. There is games rules where you have a positive variable followed by a negative variable. And then on the flip side, you have situations where you have a negative variable followed by a positive variable. So positive arrow negative versus negative arrow positive. These are very different from each other, but they appear similar at first glance. And so getting that distinction down is crucial. LSAT loves to confuse test takers by making them take one to be the other, when of course they are quite different. So I pulled it up for you here on the whiteboard. This is the in-out conditional game where we have 7 variables, D, E, F, G, H, I, J, and lots of conditionals. The indicators are only if, we have if here, we have unless here, and we have either E, J, or both, which is not overtly or not clearly a conditional indicator at first, but as you'll come to see, it actually is. Now, the first rule is a positive for gun control only if against environmental. So for gun control, we'll say voting for something is positive and voting against something is negative. So that is a positive arrow negative. So I'll type this on the side here, positive arrow negative. That means at least one must be out. So whenever you have a positive variable followed by a negative, at least one is out. You lose at least one. They cannot both be in at the same time. And so the way I think about this is that if you eat cookies, then you cannot eat donuts because they're both desserts and you shouldn't have too many desserts, right? So if cookies, then not donuts. Now, anyone want to tell me what the contrapositive of that would be? Contrapositive is very important. We want to have a handle on that. So I'll give you a second. Someone do me a favor, just type in the chat what the contrapositive would be from that one. If donuts, then not cookies. Perfect. Thanks, Colin. So if you have donuts, then you must not have cookies. So the contrapositive requires reversing the order of the variables around the arrow and negating both. So donuts was at the end. Now it's at the beginning. Cookies was at the beginning. Now it's at the end. Donuts was negative before. Now it's positive. Cookies was positive before. Now it's negative. So this is a very important kind of rule. And this is a rule that people typically don't have too much trouble with because for some reason, just innately, it's easier to think of things like this. So to apply it to this rule, gun control only if against environmental, so positive G followed by negative E. So that is the original formulation of the rule. Now the contrapositive, same idea, reverse the order of the variables and negate both. Perfect, thanks Daphne. So the contrapositive is if E, then not G. Excellent. So that is the original and its contrapositive. we should weight them equally. One is not more important than the other. They are equally important. Just because the second formulation is the contrapositive doesn't mean that it's any less useful. Now, we want to move on through the rest of the rules, but I want us to link them as we go rather than taking the contrapositive, writing them all on the side, and then combining them later. It is much more efficient to connect them as we go, because then we will naturally end up with two big chains that are the contrapositives of each other. So the second rule involves J and I, which we do not already have on the diagram. We only have G and E. So I want to skip the second rule and come back to it later in the hopes that we will more easily be able to link it on later. So I'm going to leave it to the side, put a little asterisk there, come back to it later. Next rule involves E, which we already have here. So I want to deal with this one now. So legislator votes for either E, J, or both, meaning that she must vote for at least one of the two, meaning that at least one of the two must be in. So we cannot lack both. Now, you saw earlier, the positive arrow negative means at least one out. This is very different. This is saying at least one in. So this is actually a different kind of rule. This is a negative arrow positive, meaning at least one is in. So I think of this one with a different example. And what I do with this one is I say, if you don't eat your peas, then you must eat your carrots. So not peas, then carrots. So if you do not have one, you must have the other, because they're good for you, they're vegetables. So contrapositive, what would the contrapositive of this one be? I know it's a little bit tougher. So again, we reverse the order of the variables and we negate both. So carrots is at the end, now it'll be at the beginning. Peas was at the beginning, now it'll be at the end. Carrots was positive before, and I'll help you out, now it will be negative. So what we have now is, if you don't have carrots, then you must have peas. So once again, negative arrow positive. And the easy way to think about it is, if the original is negative arrow positive, then the contrapositive will also be negative arrow positive. And if the original with the cookie donuts was positive arrow negative, then the contrapositive will also be positive arrow negative. So the negative and positive will be on the same sides of the arrows as they were originally when you have only one positive and only one negative. So to bring it back to this example of the environment and judicial bills, we're saying at least one of the two must always be voted for. At least one of the two must always be positive. So we have negative E, then positive J, and negative J, then positive E. So to write this one on the side, I'll just type not E, then J, contrapositive, not J, then E. That's what we are dealing with for this rule. So we already have not E on the diagram, so we can just take that and link on this formulation of the rule. So we just kind of take it and we put it right up there and we link it on. That's exactly what we're doing. That's it. So I'm going to link it on here and just say not E requires J. That's it. We just add it right on. I'm not really going to write on test day. I'm not really going to write this down separately and link it later. I'm going to do it in the moment, building my main diagram as we go. And the contrapositive version is not J, then E. And we already have positive E up here. So I just, once again, link it on. And linking feels a little bit weirder this time because we're linking to the front of the chain, not the end. And I get that it feels weird, but logically, it is no different. So I'm just going to take not J and stick it right on the beginning of this. That's it. I'm just going to take it and link it right on to the beginning. That's all we have to do. It is equivalent to what we did previously. So you see that we've linked the first rule and the third rule together. We're linking this one and this one over on the side. That's our main diagram. And you see we have a good chain building. We can now infer that G indirectly requires J, and not J indirectly requires not G. So we're building good inferences as we go. Now, the fourth rule is G if both H and D, so the if starts us off, right? If she votes for both H and D, then she votes for G. So we can link that on now. We don't have to. At this point, you could do either the second rule with J and I or the fourth rule. It's up to you. I might do the fourth rule now because we can link it, no reason not to. And the second rule is a little bit scary with the unless, so maybe you want to save that for last. If so, totally fine. So the fourth rule saying, if she votes for both H and D, then she votes for G. So H and D together collectively form the sufficient condition to require G. So a little tricky to diagram. I'll type it as H and D together, indirectly, together are sufficient to require G. So I might do that, kind of doing a bracket there. The two of them together are sufficient to require G, but neither one alone is said to be sufficient. It's the two of them together that require G. Kind of like having a quarter and a nickel together are sufficient to give you 30 cents, but neither one alone could do that. So I'll walk the logic of this one a bit more because it is tricky to have two things together forming the sufficient. So H and D together are sufficient to require G. That's what the rule is saying. Now, to take the contrapositive of this, as always, we reverse the order and we negate both. So G at the end becomes not G at the beginning, and H and D becomes not H or not D. This is weird. And when you take the contrapositive, becomes or, because the negation of and is or, and of course the negation of or is and. So if having both H and D together requires positive G, what that means is if you lack G, then you must have lacked at least one of H or D. Because if you had had both of H and D, then you would have had G as well. You would not have lacked it. So to diagram this, we already have not G over here at the end of the bottom chain. So we want to link this up to that, meaning we're sticking not H and not D at the end of that bottom chain. So not G leads to, and this again is a little bit tricky. Actually, you know what I'll do? I'll draw two arrows stemming from it. It becomes, not G becomes not H or not D. And of course, I'll cross this off, not H or not D. That's what that means. And so, of course, it's a little bit weird to have or in the necessary condition, but it's also weird to have and in the sufficient condition at the front of the top chain. So these really are just mirror images of each other. And that's kind of how I like to think about contrapositives, is that they are mirror images of each other. And so if a variable is at the beginning of one chain, it will be at the end of the contrapositive chain. And if it's positive in one chain, it'll be negative in the other chain. So any questions about this? I know it's a little confusing. Feel free to ask some questions or type a chat. And of course, I'm happy to address your question. Now, finally, I'm going to get into the second rule, of course, the one that we skipped. So this one's a little tricky because it has the word unless. Now, I think the simplest way to deal with the word unless is to define it as being if not. So unless equals if not. It's a simple way to think about it. So if we plug that into the second rule here, unless she votes against becomes if she does not vote against. Now, we know that essentially, in this game at least, she's only voting for or against things. There's no other options. So if she does not vote against judicial activism, then she will vote for immigration. So not voting against J means she votes for J. So if she votes for J, then she votes for I. So that just basically means J requires I. So we already have J at the end of the top chain, so we can stick on I at the end of that. So we just add on arrow I. That's it. That's all we have to do. Now, of course, we can take the contrapositive of this. Anybody want to share with me what the contrapositive of this one would be? J requires I. We reverse the order, and we negate both. Not I requires not J. I'm typing it on the bottom right there. And we have not J at the beginning of the bottom chain. So all we have to do is stick on not I at the front of that. So not I requires not J. And that's every single rule and its contrapositive linked on two main diagrams that are themselves, of course, the contrapositives of each other. And it isn't necessarily proper to think of it as the top chain being the original and the bottom chain being the contrapositive, because we might have original formulations on either one of the two. So depending on how you define the second rule, it could have been that not I, then not J was actually the original formulation. It's tricky and a little bit ambiguous when you're dealing with words like unless, or even the third rule where they said she votes for at least one of E or J or both. Who's to say if the original was not E then J or not J then E? It's really open to interpretation. It's a matter of perspective. Now, there is the question of F, free trade. This variable is a floater. There are no rules at all about it. And so you might want to mark it off on the side as being a wild card, as something to potentially have to deal with, of course, over the course of the game. So a little asterisk might be a good way to notate that. But yeah, this is a tricky game, and it's fairly representative, though, I think, of a lot of the games I sent you in the chat, like the Birds in the Forest or the Fruit Stand or the Photograph game. If you want to see a really nasty version of this, take a look at Test 31 Game 2, the CDs game. This is the game that was featured in Legally Blonde because it's so complex like that. It's almost laughable with new and used CDs of 5 different genres. It gets pretty unwieldy. That's probably one of the hardest games of all time. So this one and the Birds in the Forest game from Test 33 are kind of good warm-ups as a way to kind of dive in before getting to the tougher stuff. Now, I do have some other articles I've written that walk through the concepts in this game that I'll share with you here. I think it might be useful for you to just kind of get some practice on that conditionality here. So the cookies and donuts game and the peas and carrots thing, I've got some articles that kind of walk through the logic of those that I'll share with you here. I think it could be good for you to kind of get a basis of understanding in those. And I also do have an article where I walked through the setup for this particular game that we've been walking through. If you want to see it, as you can see, I ended up with a kind of similar diagram here on the bottom. And then for the question 7, where we add a new rule, F then not J and J then not F, I basically just added on to the end where J is. So it's kind of good for you to see that it doesn't really interact with too many other variables necessarily, but we just kind of tack it on as we need to. And Test 33 Game 2 also has a question where they add on a rule. So rather than rule substitution like we talked about earlier, Test 33 has rule addition as the final question of the game. And then Test 36 Game 1 with the fruit stand has the removal of a rule as kind of an interesting modification to the original. One of the questions that Colin had asked me before tonight's session about the contrapositive is, I think the question kind of had this idea that the contrapositive is crucial or foundational to everything. And I guess what I can say is that the contrapositive is a useful tool, but it's not the only tool that you can use in logic games. I think that being efficient in drawing multiple diagrams and dividing the game into its major paths it can go down, like I did earlier with the Juno 7 game with the numbers. I think that's an essential strategy as well. So contrapositive and chaining only applies to certain games. It applies in particular to games with lots and lots of conditional statements where we have the same variables featured in multiple rules, which suggests that we may be able to link things together to form those long conditional chains. So to go back to that game I was referencing earlier, what tells us here that we can link, we can chain things is that we have, again, same variables in multiple rules. We have gun control in the first rule and in the fourth rule. And we have environment in the first rule and the third rule. And we have J in the second rule and in the third rule. So the repetition of the variables suggests the conditional chaining. And since all the rules here are conditional in some way, that lends itself nicely to the contrapositive. Now, in contrast, a game like the one with the numbers from Juno 7, that game didn't really have conditionals. And so contrapositives weren't even applicable. There was something else altogether.